Okay. So. Math test. First one. It's today. Not even prepared. Not even prepared. Can I pause it? Whoa. I'm going to be right back. Whoa, bam. All right. I got my hat and my water bottle. Bah! I'm beaming with energy. Ah! I also got a trusty case of Slim Jims for protein. Helps the brain. Okay. I already studied a little bit. Not gonna cap. Not gonna NGL. Apparently I really sucked. Ah! So, basically, I've got this tablet open to the side, and I've got that, just the Windows Snip and Sketch with an all-black background. It's really easy to make the all-black background. And, that's it. That's all I really need. That and the other thing open on this side of the screen. But let's test. Oh my gosh. How incredible. Huh. Yep. Yep, not prepared. I'm woefully not prepared. Let's do it. So if I remember correctly, my big flaw with this here is I thought that years go on top and the jobs went on the bottom, when in reality that's not at all how any of it works. So I know that average rate of change is change in Y over change in X. So then what we need to do is it's from 1999, and this is pretty much, this form is going to be y2 minus y1 over x2 minus x1. See, that's very distinct difference. So when it says 1999 to 1997, or from 1997 to 1999, what you want to do is the opposite of what you'd think, I guess, or maybe it's exactly what you'd think. And 1999, it was 780. In 1997, it was 665. Where's my calculator? Oh my gosh. Oh my gosh. My calculator. This is so bad. Oh my gosh, I'm gonna be right back. Alright. That's it. That's it. I got everything. Man, that really picks up the fans, doesn't it? That sucks. Sorry, I'm sweating. Really, it's like 80 degrees and up in here. That doesn't sound like much. I like the cold. I'm a cold person. It's hot for me. I need it to be 60. Or at least very, very low 70s. 75. That's where I draw the line. Okay. So I'm pretty sure this is going to be something like 2. And I don't want to do that on top of my head, so. And then 780. Wow. Apparently this is 115. And it doesn't really divide up from there. It's what I'm gonna put. I don't know what to say. Oh my gosh, where is it? I can't find it. Oh yeah. So there's that. It's the first one. Now they want it from 2001, 1999. This one is going to be 2001. There was 840, and I see here this was 780. Okay, this one's only 60, and I think it's still 2. It would make sense if it was still 2. So yeah, it's still 2. But this one does reduce to 130. So that's odd. That's odd, but let's see. Wrong. Wait. Oh my gosh! I did the thing! I said I was gonna do it! Oh, I always do that. I always do the thing. Really, I should be giving myself no slack. I did it wrong. That one's still wrong. How? Calculator, 780 minus 665, 115. Divided by 2, does it really want 57.5? It probably does want 57.5. Hello? Ah, gosh dang it. Let's do this again. Am I even recording? Yeah. Alright, perfect. So yeah, change in y over change in x. Again, y2, y1, whoops, x2, x1. So I'm just going to say 2. It's always going to be 2. But the coolest thing is actually that the 2 is going to be on bottom. And the number we're trying to find, because this is going to be like year. This one's going to be year. We're trying to find 735 minus 630. Could have done that in my head, probably. 2001. It's gonna be 800. No, it's right there. 735. 65 and 65 divided by 2. 32.5, and 105 divided by 2 equals 52.5. So that should be our actual answers. Okay, there. Question 1. Bam. Next button. Alright, get a similar question. Okay, based on the graph above, estimate to 1 decimal place. Ooh, they want decimal place. X equals 1 to x equals 5. Okay, again, changing y, we're changing x. The only thing is, this is going to be and they're there, the y values, and x is 5. X, what is even that? It's like half, 1.5. And then when it's 1, oof, it's like 6.5, right? 1. That's like 6.5. 5 take away 1, that's going to be 4. 1.5 take away 6.5 is going to be -5. So -5. I don't know if that really simplifies. We can try that. That looks all sorts of goofy. No, alright, it's perfect. Great. Look at me go. A similar question. Okay, given f of x is 1 over x plus 3, find the average rate of change in the interval 6 and 6 plus h. Solve for h. Okay, so it's going to be x, it's going to be y. So, f of 6 is 1, 6 plus 3, 6, 7, 8, 9. It's 1 over 9. F 6 plus h equals 1 over, actually no, they're both x values, I think. Wait, over the interval, so yeah, that's not coordinates, they're both x values. Or I think, I don't know what a coordinate really is. Who knows? Interval, it's different. What's the difference? I don't know. Probably not good to be saying that in a video about math and tutorials and all that. I'm just thinking I'm doing something that's right, kind of, maybe. Because this looks like an input, output, you know, like x and y, something like that. So let's keep on doing this and hopefully it comes right somehow, eventually. 6 plus h plus 3, that would equal 1 over 9 plus h. Okay. Average rate of change. Okay. So, oh, get out of here. So 1 over 9 and 1 over 9 plus h. F of 6. Okay, so changing y, we're changing x. We're going to be, yeah, f of 6. This is f of 6 plus h. These are y values, these are x values. Except these are from this to that. This is 2. This is 1. So changing y, we're changing x. Let's just plug it in, I guess. No, wait. Here's the thing. Is this y or is this whole bigger portion y? Because honestly, kind of looks like this over here is the input and then that's the output. So I'm just gonna maybe try that. So y1. This is gonna be 6 plus h minus 6. This is going to be over 1 over 9 plus h minus 1 over 9. 6's cancel out. So now we're left with h, 1 over 9 plus h minus 1 over 9. I think that's what we were left with. Let's yeah. I'd like to get the bases similar, maybe. That would be more for maybe multiplication. there are different bases. So it's probably so obvious. It's probably so obvious. Hold on, give me a minute. Yeah, let's just consult the video.
We define a common denominator. We have the denominator of 5 and the denominator of 5 plus h, which means this denominator is a factor of 5. So we're going to multiply this by 5 over 5.
And the other one by h over h?
Plus h.
5 plus h. 5 plus h. Oh, alright, that makes sense actually. Yeah. So let's do that then. Nine on top. Minus 9 on top. And actually 9 plus h on top here now. All over. Be the same, wouldn't it? Be 9 times 81 plus h. 9 minus 9, that cancels out. So now we're left with h over h over 81. 81 plus h. That looks like there's one too many h's. It won't all cancel out, will it? There'll be an h and now there'll be h equals, maybe. But what we can do, I'm pretty sure we can just take one of these out, but we'd have to like represent it by like this h is really just h over 81 plus h times 1 over h. These h's will cancel. So now we're left with 81 plus h equals 0. H equals negative 81. No. In fact, we were right like a ton of steps ago. Let's just, yeah, well, how does he start? Oh, so it was that input output.
We want to combine. And now we have the information we need to find the average rate of change.
So let's like kind of use that as a guide, I guess. So there's the two intervals. Let's plug it in. It'd be the same thing plus h, you know, and it's 13, so now we have inputs, outputs, just like the video. Where'd you go? Right there. So these are going to be like y's, these are going to be x's. So x2 minus x1 is going to be like 2 plus h minus 2 over 1 over 13 plus h minus 1 over 13.
To determine the change on the fifth, then for the change in input or change in x values,
that's why.
we'll have the quantity 3 plus h minus 3.
I had my x and y's flipped. Oh, I'm so bad with that, man. It's embarrassing, honestly. It really is. That should work out, hopefully, a lot better. It looks like...
Now this is going to be a little more challenging to simplify than the previous.
Let's just, I guess, try it from here now. I really could erase all ink. 1 over 13 plus h, 2 plus h. So could do the whole 13 plus h thing. Right here. Cancel out and leave us with just h. So now this is going to be, what's 13 times 13? 169. That's the common denominator. And then this is just going to be like 13 minus 13 plus h, which, save myself some time, I'm just going to write it as h. It's really odd. It's like a pancake. What do you do with this pancake? 5 minus 5 minus h. No, mine's distribute the negative. I guess mine was a negative h the whole time. That's really tricky, actually. I could write it as 13 times 13.
This is a multiplication problem. We have negative h all over.
Really, what I could do here times, these would cancel, so it would just be like that, right? Answer? Right? That's how the answer looked the last time. I'm not going to go any further than that. That's how the answer looked. Why should I go any further? No. 13h plus 169. Lost cause. Not really. I can probably work on that question more. But there's a lot more questions in the C. That's not one of them. Oh, this thing. It's like super calculator heavy. It's just a long question. I think I know how to do it though. I remember this one from having to do it in the actual thing before it was review, when it was just homework. Oh man, yeah. It's gonna be like f of 4.1, 4.1. It's all gonna be compared to this. We have to put that into our y equals think that's right, because it's like x coordinate, y coordinate. So y on top, x on bottom, x right. Tricky part is now I got to do this for all of these guys. So it's going to be like f of 4.01, 4.01, f of 3.9, 3.9, f of 3.99, 3.99. That's going to be minus it's going to equal something, but what I got to do is I got to put it in my calculator. And hopefully this is right. It's a lot of time to waste, honestly. I'm not a big fan of just like wasting time. There's no point. Square root of x plus 3. Looks like the whole equation. But now I gotta do something funny with like vars. How do you even get to vars? They don't tell you this stuff. Alpha y equals y var. There it is. So y1 4.1. Oh, wait a second. Let's go to the video. Because I don't know, did I set it up right? Oh, because he does f of 4. But we kind of can tell like f of 4 is 5. I'm like pretty certain. In this case it's 6.
Using the calculator to find these function values. And again, we already know f of 4 equals 6 because we're given the point.
So yeah, that's 5. I'm not gonna throw at my calculator for no good reason. Although, what did his calculator look like? I think I've seen it up there. Yeah.
y1, so we'll press second x squared to the square root.
Yep, that's looking good so far. And he did. Come on, y var of that thing. Okay. I should probably actually stop exiting the video. It would help me in the long run. So y var of 4.1, subtract 5. And now I'm going to do 4.1 minus 4. This divided by this. Okay. So on this one we're getting about 0.248. Let's do it again, but then like y of 4.01 minus 5. Now we're going to have to do 4.01 subtract 4. This divided by that. Okay, now we get about 0.249. This is where it gets really cool. Oh yeah. 3.9. Subtract 5. It's a negative number all of a sudden. Why? 3.9. Alright. So it's negative 0.0. I don't have to write that down yet. Hold on, just hold on. Because, what's 3.9 minus 4? Then divide these two against each other. That's what I was thinking. There you go. That threw me off for a second. 0.251 and 3.9 minus 5. 3.99. You can see where it's going. You can clearly see where this is all going. Point 250. So from the right side it's approaching a number, from the left side it's approaching a number. That number is 0.25. See how it's coming up from here? 48, 49. See how it's, you know, coming down? You know, 251, 250. It's getting, actually there's more numbers after it on this one. It doesn't end with 0. It goes on, but it's getting closer and closer to 0.25. So let's put all that in and still get it wrong. Let's do it. 0.24, and this is the four decimal places. I'm so glad I only wrote 3. Gosh, dang it. This is where you get stuff wrong. It's where you get weird things wrong. 2484. 2484. 2484. All right. 4.01. 2498. 2498. 3.9. 0.2 2515. 2515. 2501. 0.25. Come on. Whoa! Yeah! There you go. Like I said, that problem just takes time. It's a limit, I'm assuming, from the left side and the right side, approaching the limit of blah 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 blah. But gosh dang, I get it. I get it. Whoa, I get it. Wish it didn't take so long to do something so easy, so stupid. This one I don't think I'm good with. A ball is thrown into the air by a baby alien on a planet in the system of Alpha Centauri with a velocity of 32 feet per second. Its height in feet after t seconds is given by this equation. Okay. It's odd, that squared should probably be in the front. Find the average velocity for the time period between t2 when t equals 2 and lasting 201. So velocity is 32 feet per second. Its height in feet after t seconds. So after 2 seconds, its height is blah blah blah. So the t is seconds, so it's going to be y equals 32 2 after the height in feet after t seconds is given by, this is how much time there is after these seconds. And then I would assume you do this, and then 2.01, and then 2.005. I'm assuming. Let's watch the video.
And while this is going into the air, but given determining what this point will be, do our function y of t, which gives us 31 times. On the home screen. Let's enter this in two parts. Let's first enter the numerator, and then we'll divide by the denominator. In the numerator, we have open parenthesis 31 times 1.01, close parenthesis. This amp, you find this average velocity using function notation as shown here.
Oh, okay. No, so what you're trying to do is, you've got that equation here, you're doing this change in y over change in x, and this is what you compare it to. Okay, so it's gonna be more like a bunch of these guys. It's gonna be just like it shows here, y of 2.01 minus y of 2, and then it's going to be 2.01 minus 2. It's going to be that, but like this whole page full of it. It's not, that's, might as well, it's what I've got to do. Go in, plug this into the y equals 32x minus 23x squared of y equals y vars y of 2.01 minus, let's do vars y of 2. I don't got the luxury I had last time. Okay, so I got a number, 2.01 minus 2. This divided by this. Okay, Doesn't look, I don't know what it looks like. So it definitely looks like it's getting closer and closer to negative 60. Which is weird. Why negative? It's falling. I don't know. Yeah, it's just getting closer and closer to this number. So for 0.01, it's going to be 60.23. It doesn't say to round to any number, any place. I guess if I'm close enough, it's just gonna be like, okay. Estimate the negative, oh my gosh, negative 60. Oh, snap. There you go. Wow. Okay, question 6. Let's get a similar one. Oh, easy as cake. Easy. Alright, from the left, it's approaching -1. From the right, it's approaching 2. This doesn't exist. Oh my gosh, where is it? Oh my gosh. Kept on hitting caps, not shift. That does exist, and it's 4. Uh, 13. If you don't know how I know this, sine of x over x is 1, and you can multiply the 13 out to like the top and the bottom to rationalize this or whatever. From there, 13 can slide in front of the limit, and it's just sine 13x over 13x, which is the same as 1, so it's 13 times 1, which is 13. Similar question. Oh, come on. Looks like x approaches 1, x squared minus 10x plus 9 x minus 1. So if I plug this limit in, which is usually the first thing you're supposed to do, it would be something divided by 0. So not Gucci. What that tells me is this has x over 1 in it, and it's going to cancel out. What I could do is I could divide this like x over 1 x squared minus 10x plus 9, or even do like synthetic division. But what I'm going to do is I'm just going to factor. I'm going to try it at least. It looks, yeah, that looks super factorable. So 9, 1, and 9. That adds to negative 10, makes 9. So it's going to be x minus 1. I can already see it. X minus 9 all over x minus 1. So this is really the limit as x approaches 1 of x minus 9, and 1 take away 9, that's negative 8. Oh man, I hope I didn't fail at the last possible step at just evaluating what I'm looking at. 1 take away 9, it's 8. Yeah, okay, perfect. But yeah, if it's not factorable, try division, or if that's what you're better at. Let's get a similar question. Oh, come on. These suck. These all kind of suck. Is that S? S approaches 9. I would like super recommend Nancy Pye's video on limits. She's got the best video on limits. Yeah. There's something like a conjugate I think you have to take, and not the best because just like one sign you gotta flip. And I get it wrong. Like sometimes I'll make 3 negative or something weird, and I'm thinking it's just the one in the middle. So let's see. What this is going to turn into now is the limit as s approaches 9. Let's do the top, I guess. It's 9. It's interesting. It's super interesting. I'm just going to keep it like that then. I'm going to deal with it later. 9 minus s. 3 plus square root of... That looks like s. Oh, it is. Why does it look like a 5 down here? S. Oh, man. And the bottom one, 3 times 3 is going to be 9. 3 times this is going to be plus 3 square root s minus 3 square root s. Oh, look at that. They go away. And then this is going to be just minus s. Because I don't know if I think it gets rid of the square root. No. Wait. It's s times the square root of s. No. Yeah, square root of s. I'm just going to say it takes it away. And, hey. Look at that. Hoping that I am, like, incoherent right now. I'm hoping that this is right and I didn't just, like, somehow just do something really stupid. Square root of 9 is 3, so it's 6. Wow. Yeah. Odd. Don't ask me how. That's literally me going, hey, look at that. Didn't plan. Did not plan. Did not have a long-term strategy map. That was luck. This one's not horrible. It looks worse because you're like, what is even this? It's like a over-under shotgun, or maybe it's a double barrel, you know, if you're looking at it like top down. What is this? Why is math pointing, you know, a gun at me? It's scary. It's scary. You never expect it. Like, math. Thought I could trust you. No. It cannot be trusted. Okay. So from the left, which means less than 2. And would you... Just kind of goes away then, doesn't it? Oh, I can control the screen. That's odd. I wanted to highlight it. Look. Isn't that what we're looking for? So plug it into this. So it's going to be 6 minus x squared for less than or equal to 2. And then 2x minus 5 if it is greater than 2. And it, clearly we're coming from the left, so we're plugging it into this. So it's going to be 6 minus 2 minus 2 squared. That's going to be 4. 6 take away 2 is going to be 4 minus 4 is going to be 0. I'm just going to calculate that. 6 minus 2 minus 2 squared. Yeah, it's 0. So the first one's 0. I don't know if that means it doesn't exist. I don't know. So let's do this one now. 2 from the right is going to be going to this. So it's going to be 2 times 2 minus 5. 4 take away 5 is negative 1, which is not 0, it's negative 1, which means that this limit, big old, doesn't exist. See? It's not that bad, is it? Math pointed the gun at you for your own good. It was actually a very sweet thing for math to do. It's only ever trying to help out. Okay. Well, bam. This thing looks like you can take a 7 out. And I don't know. I'm going to do it. I'm going to take a negative 7 out. And x squared minus 12x plus 35 looks like it's supposed to be a factor of something, so let's just do 35. It's 1 in 35. I don't know if it's 2 in anything. It's not. Is it 3 and anything? No. It's not 4 either. It's 5 and something. It's 5 and 7. Which gets us to 12. Make them both negative. Ah, what am I doing? Okay, first off, that is all sorts of wrong. Second off, let's keep it non-negative. That's what it's supposed to look like. 7 times 7 is 49. I remember that from an AMV. No, not AMV. A Vocaloid? No. Hatsune Miku was in it. Oh, it's called B Plus again. And it was the animated one. It was really funny. It just had to be there. Oh, yeah, by the way, alright. It's going to be x minus 5, x minus 7. Would you look at this? It's really 7 over x minus 5. And what's this limit? 7? Alright, let's plug it in. 7 over 7 minus 5. 7 minus 5. 2. 7 over 2. Caps lock, why are you on? Huh! Sorry, jump scare. What? I'm not happy. Oh. I did. Oh, that's where the mistake was. I did have to take the negative out. Honest mistake. Sorry for the jump scare. It's really my bad, honestly. It's my impulsiveness. I can't help that. I can medicate for it. Hello? Well, that took longer than expected. However, I'm back. I think I did number 11. Maybe. Oh boy, x to the third all of a sudden. Minus 8x squared plus 17x all of a sudden. X minus 5. Okay, this one's definitely division. It's gonna be x squared times, it's gonna be x squared plus 5x, x cubed plus 5x squared, and then it's gonna go into 5x squared plus 5x times, so that's gonna be 25. It's gonna be minus 25, so it's gonna be plus 25. Because whatever it's gonna be, you gotta say, oh, okay, so 5x times x is gonna be 5x squared, negate it, and 5x times 5, that's gonna be negative 25x, negate that, it makes it positive again. So yeah, so that goes away, this goes away. 5. Alright, x. How many times is it going to 25x? That would be 25 times. This ain't gonna work. Where'd I go wrong? Where did I go wrong? I know where I went wrong. Okay. Now what we have to do this is going to be 5, 6, 7, 42x. That'll be 42 times 17. Okay, hold on. Hold on. It is okay, it is 42. Okay. Goes into it 42 times. So it's 42 times -5. 42 times -5. What is even that? Plus 210. Okay. 200 as a remainder. Don't know if I'm supposed to have a remainder. What the heck? What the heck? Oh, this is so goofy. What the heck? Yeah, let's do this. No, like just the top. Bottom. I should factor it first. To the and what's this look like? Uh, 8x. Yeah, that looks about right. However, let's just copy that and say factor. That's factor. Maybe divide. Maybe divide. Yeah, what if I just do this? I don't know. I mean, it's not like you can just do another one on the test. So when this happens on the test, I'm gonna start over again. And as x approaches 5. Okay, x squared times. It's gonna be x to the third plus 5x. negative 8 plus 5, negative 3. That seems different already. Negative 3x squared plus 17x. It's going to be negative 3 times. Wait. Negative 3x times. This is going to be 3x squared. Technically, that's negative. Negative times a negative is a positive, so that's going to be negative 15x. 17 minus 15 is 2. 2x minus 10. X goes into it 2 times. Positive 2. It's gonna be a 2. That's gonna be a 10 of some sort. There's gonna be a positive. It's gonna be a negative. Ooh, ooh, there was a trick in there. 0. Okay. But anywho. Wow. Now that we got that information, what we can do is, now the top number thing, yeah, sorry buddy, you gotta go. You gotta go. Whoop. This is all over x minus 5, correct? Well, guess what? Since I divided this and it turned out to be this with no remainder, it's actually a factor of it. So I can do that, and now the limit is just as x approaches 5 of x squared minus 3x plus 2. It's going to be 25 minus 3 times 15 plus 2. So it's going to be like 10 plus 2, 12? Yeah. Yup. Bam! Didn't give up. Just was bad at math for a second. There's a difference. Oh. Man. Let's see, how are we so far? Ooh, number 3, that's gonna kill me. We'll come back to it. It's interesting. I think we ought to do the same thing we did last time, but topsy-turvy. Cattywampus. So, let's just do it. It's gonna be a lot longer. Plus 8. Ooh. Okay. And let's leave this as x times 6x plus 64 plus 8. Let's leave it like that. And this top one, okay, square root of 64 times the square root of, that's just gonna make it go away, 6x plus 64. And then that, oh, what the heck? What the heck? Oh my gosh. I don't know what to do. What the heck? Yeesh. Yeesh there, buckaroo. How'd I do this? How the heck did I have a green last time? What the heck? That was me earlier today. What the heck? Oh my gosh. Wow, I'm getting worse at math as we go along. How could this be? This is supposed to be studying. Maybe I shouldn't have put it off till like Thursday. And the test was on Friday, which is today. And it's like 6 o'clock. He said you got the whole day to do it. I hope he didn't mean the whole school day, because I'd have just missed my first math test. I'll do this test at 10 o'clock. Leading up to midnight. I don't care. I want to be prepared. Man. I'm not prepared. Look at this. Oh my gosh. Well, let's just see what we got here. Alright, alright. Get rid of it. Square root times 8? No, that's a little bit strange, so we say no. What's the video say? I'm beat. What's the video say?
So the secret will be square root.
Yeah, looks good.
And then we have the square root of x plus 1 times 1, which would be plus the square root of x plus 1.
Oh.
But then notice how we have negative 1 times the square root
Yeah,
of
but
x
like,
plus 1.
what if it's times 8, buddy?
So then we have minus square root of x plus 1.
Well, let's see. 8 square root of 6x plus 64. I think it's going to go away anyway. Minus 8. See, okay, so it goes away anyway. I see. So now it's just negative 64. And in fact, that makes it go away. So now all we have left is 6x all over x times square root of 6x plus 64 plus 8. These x's are going to get got. So now all we have is 6 over the square root of 6x plus 64 plus 8. And at this point we can probably throw 0 in there. So 6 times 0 is going to be 0. Square root of 64 is 8. So it's going to be 8 plus 8, which is 16. So it's 6 over 16, which I don't think simplifies. There you go. It just looked scary. It just looked scary. I was scared. That is intimidation. Ain't nothing. F of 8. Y is 8. No. It has to be x, because there's no f of x. So when f of 8, what's y? It's 5. Oh. From the 6, from the left side. 6. It's 4. We'll get that. 6 ain't really on somewhere special. 1 from the right. 1. What's square root? 2 DNE. Because 2 is... No, it definitely does exist. It's 2. None of these are tricks. Wow. See, if it was 3, it would be, it does not exist. If it was 1, it wouldn't exist. But 2 definitely exists. That was really weird. They should have tricked me. Did something funny. No, they didn't. They're gonna trick me on this one then. Whoa, what is this? Okay, I think I remember this one. 0. Yeah, okay, I got that one. Okay. Okay, so gotta explain. When it looks like this, you've got no idea, because it's like, whoa, what is going on? Then you just take rise over run. It's 1, straight up just 1. These, however, these are actually interesting and junk. So, f of 5 from the right. 5 from the right is 2. It's approaching 2. So it's 2 minus 1. So it's 1 over f of 6. 1 over 6. This one's going to be cool. It's 3 from the left. It's going to be 3 plus 1, which is 4. So then it's f of 4 from the left. 4 from the left is going to be 1. That's wrong. 1/3? 5 from the right is 2. Take away 1. 1. 5 from the right is 2. 5 from the right. 2. 5 right. 2 plus 4 is not 3. I don't get it. F of 1 is 1. No, I just get a similar question. Let's do this one again. Let's just do the top one. Okay, 2 from the right. 2 from the right is 2. 2 take away 3, negative 1. Oh, negative 1. Negative 1. Okay. 2 is 4. 1/3. Let's watch the video.
We're going to determine the following limits using the graph of f of x provided here in red. We first have the limit as x approaches 3 from the right, from the positive side, of f of x minus 3 divided by, we're looking at the denominator, notice as x approaches 3 from the right, the input into the function would be approaching 3 plus 3 or 6 from the right. So going back over to the graph, here's where x equals 6.
Wait, what?
We're approaching 6 from the right or from the positive side. We're approaching from this direction here. And notice how...
Oh. Okay. Yeah, big dummy. Big difference between what it's asking. See how this is inside? It's asking this number here plus 3, not the answer, then add 3. I get that now. I get it. Let's do the answer. Let's solve it. 6. 2. 2 from the left. It's gonna be 2. 2 plus 4. See how I knew it in here? 2 plus 4 is 6. F of 6 from the left is 4. This one. F1 from the right. Approaching 1. 1 take away 4 is negative 3. Over 1 from the right. 1 plus 3 is 4. 4. Approaching 4 from the right is 3. So it's negative 3 over 3. Oh, yeah. Yeah. Haha. Goodness. Need some water. God dang. Woo. I'm gonna pretend like I didn't see that while I was sipping that, even though I already knew it. Oh man. Oh man. Four, 10. Just plug it in. Just plug it in. Bang. Let's go. Too easy. Too easy. Far too easy. Get this calculator out of here. Who even uses that? Who uses a calculator? 2 times 2 is 4. 4 to the 4th is like 32. Or 64 actually. No, my god. 4 to the 4th? It's 256. 4 to the 3rd is 64. 4 squared is 16. Okay. Okay. So we got 256 minus 8 times 2. 16. 256 subtract 16. Is it really 240? It doesn't seem like a right answer. Because it isn't. It's so clearly not. You dummy. How could I? 1 to the 5th? I think that's just 1. I think it's perpetually stuck as a 1. So it's 7 times 1. So it's 7. Okay, 7 minus 6 is 1. That one's a fluke. I'm going to keep it though. Oh, I never got 19 right. Because that's where I stopped. Oh my. There's 40. Takes me about an hour to get through 10. Oh yeah. Oh yeah. That's a lot. That's a lot. Well, you gotta do what you gotta do. I should have done this throughout the week, honestly. Would have helped me a lot. Really, really don't like myself that I didn't. Nope. There's a clever solution to this that I can't think of now. Oh, yeah, I can think of it now. It's something like y minus 5. There's a formula that I never learned. Never learned it in school. There's a formula. Secret formula. Krabby Patty formula. B squared.
Now we'll look at 2 examples to show how factoring can be helpful.
Oh snap. Did I get it right?
In both cases, we have the limits of rational
A
functions.
squared, yeah.
First, we have the limit as x approaches
AB
2 of the quantity x squared
8 times
minus
3.
x
No.
minus 2
No, it's close.
divided by the quantity x squared plus
That was
x
close.
minus
Why
6.
5? Why only?
Before we factor this, though, let's look at the graph of this function.
It's A, that's B, A squared.
Notice how
Oh,
the
come
graph of
on.
the function has
Yeah, but if I pause it, I can't see it.
Notice in both cases,
So,
we have the limits of rational
A,
functions.
B, A
First,
minus
we have the limit as x approaches 2 of the
A
quantity
squared,
x squared
AB,
minus x minus 2
B squared.
divided by
Plus
the
B
quantity
squared?
x squared plus x minus 6. factor
Oh, I
this
hate
out,
that so much.
let's look at the graph of this function. Notice how the rational function
Plus b squared.
as a whole at x combined
Is it really
minus
plus on
x
both ones?
squared plus x minus 6.
Because it's
Before
it's
we
this
factor
minus
out,
this, then
let's
it's
look at the
minus
graph
here, and
of
then
this
plus to
function.
the rest. It's weird. That's just weird.
Notice how the rational divided by
Yeah, plus
minus
plus.
x squared
Yeah.
plus x.
Okay. I can roll with that, I guess. So it's really the limit as y approaches 5 of y squared plus 5y plus 25. I don't know if there's anything else I have to cancel out. I could probably just plug her in. It's going to be 25 plus 5 times 5 is 25 plus 20. Is it really going to be 75? Yes! Oh my gosh. I was so close to remembering that. Gosh dang. Gosh dang, son. I've been doing this since 6 in the AM PM. I had a lunch break. I had a breakfast that I made myself. And now we're reaching the part where it ain't so much a review as much as it is learning. Because this is as far as I got. I haven't gotten to 20 yet. This is new. This is now new officially. So that's as far as I could get from 6 in the morning till like 10. Which is sad. Sad that I couldn't even get to 20 questions. But that's me. I'm slow in that. I really truly am. This one, just evaluating it, I guess. Pop it, get it all out because it's gonna cancel. That H is horrible. 7 times 749 plus 7H plus 7H, that's plus 14H. Plus H squared minus 49. So now we're left with 14H plus H squared all over H. Kind of cancels like that. Maybe 14 plus H. Come on, don't yell at me. It's just 14. So where'd the other H go? What? So there's an H squared with one H on the bottom. H squared with one H on the bottom. And somehow there's no H when it's... Oh, because H approaches 0. When you plug in 0. Okay, that makes sense. Then I come back to these. Didn't like it. Didn't like it. Don't want to like it. Weird. Gross, weird math. Gross and weird. It's all weird stuff. So that's what it is like till question 30. Okay. It's odd. I'm actually absolute value. I'm not really good on it. That was the unit that COVID took out from my algebra. A big portion actually. There's like 3 months of like the actual, like most of Algebra 2 was reviewing Algebra 1. Like the last 3 months were actual work, and those were the COVIDing. I didn't have a pre-calculus. So this stuff is freaky to me. Like freaky stuff. I don't know how to break it out of jail. See, he's got like bars. Don't know how to break it out. Don't know what to do. What's the opposite of absolute value? Time to watch the video.
Welcome to 3 examples of determining limits involving an absolute value function. We'll first determine these limits graphically, then determine the limits algebraically. Notice all 3 limit function as a piecewise defined function. Looking at just the absolute value part of this function, notice as long as x is greater than -3, the value inside the absolute value would be positive, and therefore we would not need the absolute value. So again, as long as x is greater than -3, we can just drop the absolute value and say the function would be equal to 4 times the quantity x plus 3 divided by the quantity x plus 3. And notice in this form, x plus 3 over x plus 3 would simplify out, giving us the constant function f
It makes sense.
4. Again, as long as x is greater than -3.
But that's not what they gave me,
Next,
sadly.
notice that x equals -3 is not in the domain of this function. So now we'll consider when x is less than -3. Notice when x is less than -3.
But that is interesting to think about. So this is just giving off a piecewise, which is this like squiggly thing here breaking off into 6 plus 1 minus x over 1 minus x, which would cancel out, make it really snappy, great, easy. The other one is 6 plus -1 plus x. Don't know. He's distributing negatives, and there's, you know, a 4 in the front, maybe because there's nothing in the front, you just hop it up along. 1 minus x, which different, yeah, doable, probably.
Have a number inside the absolute value. The absolute value would make it positive, which means when x is less than -3,
Pretty much this is just telling me to use
take
this.
the opposite of the quantity x plus 3
So let's
equal the absolute value.
let's try that then. You know, no dilly-dallying. 6 plus -1 plus 1 over 1 minus 1. It's gonna be 6. Come on. Come on. Play nice. 5. 1 take away 1, 0. 1 minus 1 is 0. Something's goofy. Well, let's just use that logic again. There's nothing wrong with that. Let's try it again, see what happens. So it's 1 from the left again, so it's going to be the bottom one. Okay. Hate to break it to you, but we're going to distribute that negative again, just like last time. And I'm going to expect a different outcome. I'm going to expect the answer to be right. So what this is really is negative x or -1 minus 1. -1 take away 1. It's going to be -2. It's going to be a 1 minus 1, which is going to be 0. So we have 6 plus 2 over 0. I don't think 2 over 0 really actually is a thing. Let's try it in the calculator. 6 plus 2 over 0. And again, divide by 0, error. There's an error. Error, as it turns out. What's this video say about that? Come on.
Welcome to 3 examples of determining limits.
See, that would never give an error. -3. That might.
3 from the negative side. That's when. Then finally we have the limit as x approaches -3.
It does not exist. Alright. I'm assuming that's because there's a 0 involved. Nope! It exists and it was 7! How? What? What? It exists. It not only does it exist, but it's 7. Which means I should have gotten a 1. 6 plus 1 is 7. So how would I make that equal 1? It would also have to be -2 on the bottom. How would it be -2? Well, it'd have to be -1 minus 1. We didn't have that. In fact, there's no real way I could ever put in x to make it. Well, I know why. Because this actually should be a plus. So it should still be 0 over 0, which is even more scary. So, I'm going to watch this video, hopefully learn more.
3 over x plus.
How about the second one? How about the second one, buddy?
First one x on the left approach -3. That's where we have a -3.
Wait.
As x
Either way it crosses out?
second piece, we have a negative sign here. We drop the absolute value, and again, notice.
Ah, wait. So it's just multiplying it by a 1 or a -1? Number in front. Because it's from the left. But that don't make sense. So I'm going to be adding. That video ain't really lining up with the math here. So I'm gonna have to hard logic solve this with my own noggin. And ain't a good place to learn, I'll tell you that much. Trust me, I lived in it once. Absolute value. 0 minus x. They want me to do something different. That's why they're flipping flapping them. See the flip flap going on there, Sonny boy? And they tell me that there equals 2 different outcomes. And if I pull up this here video, it tell me them exact outcomes, believe it or not. And them's exact outcomes would be that if it's greater coming from the right side, that this is going to be a positive number up here. So it's going to be this is the funny thing about this. There's no number out front. Technically, maybe you could see this whole thing is like a hidden 1 because if it's something over something. So it's going to be either +1 or -1 is what they're saying. Because this is from the left side, I'm going to say this is going to be 4 minus 1. Now let's just say if my hypothesis is true. What the darn heck, my gosh darn brain somehow solved something. Let's see if that holds true for them all now. Because from the right side it's going to be 8. If you just watch this here. It's wrong. Why is that wrong now? All of a sudden that hypothesis I just had, it ain't holding out so true. Let's see. From the right side, if it's from the right side, is it -1? From the right side, is it 2? No. It's 4, like I first thought. It's from the left side. It's going to be minus 1. The heck, is that just going to be minus 1 then? So yeah, from the left side it takes away 1. From the right side it should be 4. Okay. There's a pattern here. Left side, take away 1. No. Pattern's busted. I don't get it. I don't get it. That's mismatch. That's mismatch, yeah. That's mismatch. That's mismatch. Right side 7. Oh, it works some of the time. That's what is bugging my brain, because it should work all the time or none of the time. But if my logic works only some of the time, then I can never understand it. This is bugging me more than you'd ever know. Right side, mismatchy, missy-matchy. Right side's plus 1. Technically there's 1 there too. Right side takes away 1 this time. What's different? Let's see. This minus that, this minus that. Missy-matchy, correct. This minus that, missy-matchy left side, negative 1. Added 1 that time. What's actually the difference? What is the difference? Okay. From the left side, for x approaches theta minus x approaches theta positive. Let's just check it. Let's just keep checking it until I think of, oh, that's easy. When this happens, then that happens. Okay, from the left side, it's going to be minus 1. And it, in fact, wait a second. The heck, I got a Bluetooth thing over there yelling at me. Some kind of Alexis. Nothing, in fact, did I even say came close to Alexis, although it worries me because we have one downstairs. And if that thing picks up my mom's voice from downstairs amidst the air conditioner and the fan, that is a very, very active microphone, and it can hear everything everyone's saying. There is a conspiracy in this household. Unless I said Alexa somehow. That'd be creepy as well. I don't remember. I do not recall. Okay, so I'm saying something funny here. So sometimes it's x minus that thing over that thing x. Other times it's the opposite, like we see here. So maybe this has some very crucial role in what goes down, although I can't see how the order would change much. So while that's on the left, let's assume it's flipped. And let's say it's minus 1 and plus 1 for x approaching let's see. This is science at work. This is going to be the opposite of what I think, so I'm thinking this is going to be a plus 2. Okay, fluke. This one's following the bottom. It's from the left, minus 1. It's from the left, follows this formula. Should have been a plus 1. So It's going to be 1 point for that guy. I just don't know. Get a similar question. Okay. Whoa, that's the thing there. Woo-wee! Okay. Maybe that's what I'm missing. Alright. It's going to be 1. No. That's a negative 1. Which follows the theory of the top one. It's 2 points. Okay, it's from the right. It's topsy-turvy. Let's change this model back to how it used to be. Okay, following this model, it's different all of a sudden, and from the right you take away 1, so it's 3. Okay, 1 point for this one. Okay, regular old model. I'm going to say this one's AKA x minus theta over x minus theta. I'm going to say it's AKA this model. AKA. This is going to be from the left minus 1. Looking good. 1 more point. Now let's see. It's following the bottom model in a way. As you can see, the x's do not line up with either of that. So from the right, it's going to take away 1 and be 4. Whoa! I think I have came to the scientific conclusion that possibly also that could also follow that formula. I have yet to see it though. Top formula. From the right, it's going to be plus 1. I think I got this thing right down. Bottom formula, negative 1. Now, the funniest thing is, and this is the funny thing about this, how the heck am I? That's just memorization. There ain't no math involved there. I want to understand what is going on. I just don't want to be able to answer it, even though I just deduced this here formula. And because that's from the right, and because it's following the top model, it looks like that's going to be an 8. And it's perfect now. It's flawless. It ain't bugging me so much. What's bugging me is, why the heck does this bottom one even exist? How the heck's it flip sometimes? So, I'll tell you what I do. I take a screenshot, mode, full screen snip. That's it. Saved it. Copy it if I have to. There you go. I'm going to save that. It's bugging the junk out of me. Why the heck is it flipped? Moving on. Moving on. F of 2 is defined. Check. Limit exists. Check. Limit does not. Function is continuous. No, there's a hole there. Bam. Alright. F of 2 is defined. Limit does not exist. The limit doesn't exist, so it can't equal that. The function is, yes, continuous, because there's not a gaping hole. Oh. It's not continuous. No. Wait, huh? Get a similar question. Okay. F of 2 is defined. It's not defined. So the limit doesn't exist. Function is continuous. Oh, because I have to have all of them. Oh, okay. Function is defined. Function is continuous, I guess, because there's a gap in it. It's filled there. But the limit doesn't exist. Yeah. Function is not continuous. Okay, so it isn't continuous. So it's defined, but it isn't continuous. That makes a lot of sense. There is, in fact, a break in there. Even though at a point you can kind of have a plot on it. There isn't a circle here with no black dot above it. Oh, actually, you know what? The other one, there was that. That makes a lot of sense. That was a gap in my logic. F of A. What's f of A? What even is f of A? X approaches A. What's A? It's defined. Sure, why not? It's here. There, it tells me where it is. Is it here? Yeah, then it also exists. But I don't know. It can only equal 1. Ooh. X equals -1. It's defined. No? The limit exists. Determine which of the following rules for which of the rules is violated? Select the first rule violated. Okay. I thought it was... I didn't even read the question. I don't know what I thought it was. Determine which of the following rules for continuity is violated at 2. No, it exists, but it isn't defined. Two. It's defined and the limit exists, but it does not equal that. Ah, what is this? It's a triple barrel shotgun. Pew pew pew. -3, -3, -3. In fact, it almost looks like funny faces. But I don't even know what digress means. People always say it when they're done rambling about nonsense. I don't know if it's what I do. I really don't. Maybe there's irony in there somewhere. Maybe what I just said there was ironic. Let's move on. Select all the statements you agree with. Ooh, I like agreeing with things. Note you may check more than one box. No partial credit. This is... I'm so glad it's not being graded. 3 is defined. It says how equals that. It says 2. So yeah. Limit exists. It looks like it's 2 different equations depending on left or right. So I'm gonna say it doesn't. Function is continuous. Ooh. Not continuous. Nope. The limit exists. Apparently. How would I check that graphically? Giraphically. Those 2 videos are how? Okay. F of x is a function which is continuous everywhere. Then we must have b equals. Then we must have b equals. Now for fun, try... How is it fun? How can I try to graph it? Where's the graph you've given me? This is rigged. What do we solve for B? There's a video. Shoot. Oh. Really? I have to click on the actual video links. That really
If
sucks.
we want to determine the value of b, this constant here, that would make f of x continuous everywhere. Well, if f of x is continuous everywhere, that means we should be able to sketch this piecewise defined function without lifting up our pencil. Notice both function rules for this piecewise defined function are linear functions, which means the only place where this function could be discontinuous would be at x equals -1. So while we do have formal rules to determine whether a function is continuous at a point, I think it'll be easier if we take a look at this graphically. So for example, if this was our piecewise defined function,
Yeah, it'd be
notice
great to
how
look at it
nothing
graphically.
continuous
I'm so
everywhere.
good with
This is a
graphs.
break in the graph,
Not good with
x
like
equals -1.
triple barrel
Think
shotguns.
that we have to lift up our pencil in order to sketch this graph. But if this was the graph of our function, notice how we can sketch it without lifting up our pencil, and therefore this function is continuous everywhere. So notice that when x is equal to -1, these two functions would be equal to
whoops.
each other. And that's our strategy in order to determine the value of b. When x equals 1, 5x plus 3 must equal -3x plus b. Again, in order for this function to be continuous everywhere, 5x plus 3 must equal -3x plus b when x equals -1. So for the first step, let's substitute -1 for x. So we'd have 5 times -1, that's -5, plus 3 equals -3 times -1, that's 3, plus b. Now we'll simplify and solve for b. -5 plus 3 is equal to -2. Subtract 3 on both sides. We have b equals -5. So when b is equal to -5, this piece equals, in order for this function to be continuous everywhere, 5x plus 3 must equal -3x plus b when x equals -1. So for the first step, let's substitute -1 for x. So we'd have 5 times -1, that's -5, plus 3 equals -3 times -1, that's 3, plus b. Now we'll simplify and solve for b. -5
equals
plus 3 is
-5.
equal to -2. Subtract 3 on both sides. And we have b equals -5. So when b is equal to -5, this piece
Really the whole thing? It's a double barrel shotgun, sorry. Sorry I even said anything. So let's look at this logically then, just how the video said. So 2x minus 1 equals -4x plus b. When x is 8. I'll plug x in. 2 times 8, 16, minus 1, 15, equals -4 times 8. Is that also 16? No. No. 4 times 8, 32. Minus 32 plus b plus 32 plus 32. 15 plus 32 is 47. B is 47. That's 30. Oh my gosh. Oh my gosh. 47. Something feels off. No, nothing feels off, I guess. Interesting though. It's very interesting. Alright. However, it is time to take another break. Oh, we're so close. Last 10 questions coming up. It's fiery about it. Gotta take a small break though. Every hour you gotta take a small break. It's the best practice. Just kidding, it's my practice. I'm gonna call it the best because it's mine. I'll be right back. Well, lost the hat again. Voice crack! Ah! Well, lost the hat again. Alright. Last 10. Let's go. Yeah. Yeah. MX. Function is continuous everywhere. Well, given what we just did in the last one, wait. You know what the funniest thing is? Shoot. Hold on. Only goes to about 1.3, chapter 2. Weird. Yeah, it only really goes to 1.3. Gradebook. Let's see. 18. It's the 17th. So, ouch. I actually have a ton of this to do. Like, that's all due by tomorrow? Weird. But that's, I think, what I'm... Wait, 2.0? Wow, we're starting chapter 2. But, yeah. Continuous functions. Yeah, I'm already pretty much doing all that stuff in just the review, which it's kind of funny. It is and it isn't. You're given a test Friday for stuff that's due the day after. Apparently it's on the test. I mean, I guess he gave it out. Technically, you can do any of the work at any time. But it's kind of goofy giving a test Friday for work that isn't due until Saturday. Shoot, that's why all this stuff seems so new to me. It all makes sense now. What the heck? We got about 10 questions. Woe is me. Woe is me. What should I do? Should I review the 10 or, better yet, kill 2 birds with uno stone and just do these graded assignments? You know what I mean? There's a grade book right here. Boom. Maybe it just so happens that I go like this on a couple of oh, maybe I just so happen to go like that on a couple of them. At least the ones I didn't do. Yeah, that's the bulk of it. That's what I didn't do. Okay, well, let's get graded for it then. Oh, I just did all this stuff. Shoot. It's like, why'd I even do it then? I reviewed it, but I didn't do it. Oh man. Well, this is easy for me. So it's defined, and the limit exists. Function isn't. I mean, technically, you don't have to lift the pencil. I don't think you have to lift it, so I'm gonna say, yeah, why not? But it isn't that. Whoops, I meant to say that. Apparently, it's not continuous because there's a circle, open circle. It is defined. The limit does not exist. It does not equal that, and it is not continuous. It's defined. The limit does not exist. It is not continuous. Well, actually, it's undefined. Firstly, it's defined. The limit exists, but it does not equal that. Oh, you make me so mad. The triple shotgun. How could I forget it? Well, pretty easily, as it turns out. As we're learning. Alright. Now, it is defined. The limit does exist. It is no. Yeah. But I'm not seeing equal to. It's defined, it exists, and it's not continuous. Yeah, that's what I said. I don't get it. Yes, it is defined. It looks continuous. No. It's not continuous. But the limit does exist. Okay. Because there's no equal to. It's continuous everywhere. Just did this. Easy squeezy. Eight, 16, 24. Yeah, 24 minus 5 minus 2 times 3 plus b. That'd be negative 6 and 6. That's going to be 25 equals b. Whoa. Whoa. Where's my flaw? Show me. 35. Let's do it all over again. Well, this is going to be 9 minus 3, which is going to be 6, equals negative 2 times 3, which is going to be minus 6. So b equals 0. No, weird. I swear this is how it's done.
Whether a function is continuous at a point, I think it'll be easier if we take a look at this graphically. So for example,
It's always easier to take a look at it graphically.
Must equal negative 3x plus b. Notice how we can sketch it without lifting up our pencil, and therefore this function is continuous everywhere. So notice that when x is equal to negative 1, these two functions would be equal to each other. And that's our plus 3. So we'd have negative 5 plus 3 is equal to negative 2, negative 5. And negative 1 would be negative 3x minus 5. So if we go back and take a look at our graph for a moment, minus 5, notice how...
Okay, I'm gonna just do it again. What? Okay. 6x minus 6 equals negative 2x plus b at 10. 60 minus 6 is 54 equals negative 20. Add 20 to both sides. 5, 6, 7. That's 74 equals b. What? And it works. What the heck? I mean, it's me. My mental calculator's rusting. Currently. Not resting. You're rusting. Yeah, that is not to kill you. So I hear you think I need help. So I hear you think I need help. Well, I have to take notes on this. Notebook, come here, buddy. It's one of yours. Well, it was one of yours. Yeah, I grabbed the right one. Okay. I know, I've actually almost burned through this thing. And this is like week 3. And I'm already like this much of the way through it. Like, man, there's barely any pages left. And what we do is we unplug this. We set this aside. We can be repurposed for later batches. And that sets right there. Now I get my trusty pen. Always so trustworthy. And then I don't even know if you guys want to see this. But I mean, it's the real deal. It's the real stuff. It's what you do.
Welcome to a lesson on continuity. The goals of this video will be
Oh,
to
it's so...
define
It's overdone.
continuity using limits, determine if a function is continuous or discontinuous at a given point, and also to determine the types of discontinuity. When you took algebra, you may have determined if a function was continuous by determining if you could sketch the function without lifting up your pencil. If you can sketch the function without lifting up your pencil, it is a continuous function. If you cannot sketch the function without lifting up your pencil, it has some sort of discontinuity and is not a continuous function. We want to revisit this idea and also determine if a function is continuous at a specific point. Let's take a look at a definition of continuity involving limits. A function f is continuous at x equals a if it satisfies these 3 conditions. F of a exists, the limit of f of x as x approaches a exists, and also that the limit of f of x as x approaches a is equal to f of a, meaning you can find the value of that limit by performing direct substitution. A function is continuous over an interval if it is continuous at each point in that interval.
Oh, just barely missed it.
A function is continuous over an interval if if it is continuous at each point in that interval. Before we look at some examples, let's talk about two types of discontinuity. Here are two functions that are not continuous if it is continuous at each point in that interval. Before we look at some examples, let's talk about two types of discontinuity. Here are two functions that are not continuous. They contain discontinuity. Now this first function, you can see, is really only discontinuous at this point. If I was to take this point and move it back down into this position, it would then make the function continuous. This is called removable discontinuity. F of x can be made continuous by appropriately defining or redefining f of c. Now this function could not be made continuous by redefining a single point. You can see here that it has a vertical asymptote. This is called non-removable discontinuity. F of x cannot be made continuous by redefining f of c. This type of discontinuity occurs when the limit does not exist at c. Let's take a look at an example. Determine if the given function is continuous at x equals -2, 2, and 4. Let's first consider x equals -2. So we're looking at the function in this region here. And remember, we want to state if it is discontinuous, which it looks like it is, what is the reason behind it being discontinuous? So I rewrote the three conditions down here that we can verify. First, f of a exists. Well, in this case, f of a would be f of -2, and f of -2 would be equal to a -1 from our graph, so it satisfies that condition okay. The next condition, the limit as x approaches a must exist. So we're trying to figure out if the limit as x approaches -2 exists. Remember, to determine this limit, we must approach -2 from both sides. The right-sided limit looks like it's approaching +1. The left-sided limit looks like it's approaching -1. Therefore, this limit does not exist. Therefore, we have a function that is not continuous at x equals -2. And in fact, this would be non-removable discontinuity because we could not make it continuous by just redefining this one point. Let's now consider this function at x equals 2. So now we're concerned about the function at this point. So again, we must satisfy these three conditions, and right off we can say that f of 2 does not exist. Therefore, we have a function that is not continuous at x equals 2. But the type of discontinuity here is removable. If we were to redefine f of 2, we could make this function continuous. Let's take a look at it at x equals 4. At x equals 4, let's see, does f of 4 exist? It does. Looks like it would be equal to +2. Next, we need to consider the limit of this function as x approaches 4 and see if this exists. As we approach 4 from both the right side and the left side, we can see that we are going to be approaching this closed point here. Therefore, this limit will be equal to +2. So we verified f of a exists, we verified the limit exists, and now we need to make sure that we can find this limit by doing direct substitution. The last thing we need to verify is that the limit can be found by performing direct substitution, in this case, when x is 4. So notice that f of 4 is equal to 2, and the limit is also is equal to 2. Therefore, this confirms that this function is continuous at x equals 4. Okay, I hope that helps explain how to determine if the function is continuous at a given point.
All right.
Also,
check.
Suppose that f of x is a continuous function with f of 1 equals -4 and f of 5 equals 3. Determine which choice best describes the following statement. F of x equals 0 for some x in the closed interval from 1 to 5. And our choices are always false, sometimes true and sometimes false, always true. Notice the closed interval from 1 to 5 come from the inputs of the function, notice how the outputs, or the function values, are opposite signs. One's negative and one's positive. If f of 1 equals negative 4, a continuous function must pass through the point 1 comma negative 4. And if f of 5 equals 3, it must also pass through the point 5 comma 3. So the key here is that our function is continuous, and it must pass through these 2 points. Let's take a look at this on a graph. If our function is continuous, that means we must be able to sketch it passing through these 2 points without lifting up our pencil. So it should make sense, if we sketch our continuous function passing through these 2 points, it must cross the x-axis at least once, and the x-axis is where the function values would be 0. So our function might look something like this. Notice here, f of 4 equals 0, and 4 would be in this closed interval. But there may actually be more than one x value in this interval where the function value would be 0. We can sketch a continuous function over this interval with more than one x-intercept. For example, the function might also look something like this. Notice in this case, there are 3 x values in this closed interval where the function value would be 0. Here at x equals 2, 3, and 4. So regardless of how many x values are in this interval, such that f of x equals 0, there must be at least one because the function is continuous. So the best choice would be always true. Let's take a look at a similar question. Here we're told that f of x is a function with f of negative 1 equals negative 3 and f of 6 equals 2. Notice here we're not told the function is continuous. Determine which choice best describes the following statement. Again, f of x equals 0 for some x in the closed interval from negative 1 to 6. Once again, notice that negative 1 and 6 are the given inputs, and the outputs of the function values have opposite signs. If f of negative 1 equals negative 3, then the function must contain the point negative 1 comma negative 3, and if f of 6 equals 2, the function must also contain the point 6 comma 2. Let's take a look at this on the graph as well. Again, we're not told the function is continuous. It may or may not be continuous. We know if it is continuous, and it passes through these 2 points, there must be at least some x value in this interval where the function value would be 0. For example, here, the function value would be 0 at x equals 3. But what if the function is not continuous? Could we sketch a non-continuous function over this closed interval that does not pass through the x-axis? And the answer is yes, it could. It might look something like this. We pass through this point here, have a break in the graph at 4, and then begin at 4 again above the x-axis, let's say here. Notice how we do have a function that passes through the given points based upon the given function values, but there is not an x value such that f of x equals 0. Which means in this case, our best choice would be, it could be sometimes true and sometimes false, based upon whether the function is continuous or not. So this idea leads us to what's called the intermediate value theorem. The intermediate value theorem states that if our function f is continuous on a closed interval from a to b, and k is any real number between f of a and f of b, then there is at least one number c in this closed interval from a to b such that f of c equals k. As an illustration, let's take a look at this function here. Let's consider this function on the closed interval from negative 3 to 3, or from here to here. Looking at this point on the function, notice f of negative 3 equals negative 2. And considering this point on the function when x equals 3, notice how f of 3 equals positive 2. So now we're going to pick a value k between f of a and f of b, or in this case, between negative 2 and positive 2. Now in our previous examples, we considered the function value of 0, but it doesn't have to be the function value of 0. Let's say we consider the function value of positive 1. Notice how y equals positive 1, or f of x equals 1, would be anywhere along this horizontal line. And notice on the closed interval from -3 to 3, there are actually 3 x values in this closed interval where the function value would be positive 1. The function value is positive 1 here, here, and here. And therefore the values of c, or the values of x in the closed interval, with a function value of positive 1 would be here, here, and here. And these x values are guaranteed by the intermediate value theorem as long as the function is continuous on the closed interval from a to b, or in our case from -3 to 3. I hope you found this helpful.
Alright, sweet. 2 videos done. In fact, that's go to the grade book. That's 58% done. This is 100% done. And I've got 4 things to go. Well, half of them are video assignments, so that's not bad. So I really only got 2 things to go after this and after my test. Well. Just kidding. Let's go.
We want to find the value of m to make f of x continuous everywhere. Well, notice f of x is a piecewise defined function where m would be the slope of the line when x is less than or equal to -2, and when x is greater than -2, we have a quadratic function. Well, we know that a linear function and a quadratic function by themselves are always continuous, which means to make this piecewise defined function continuous everywhere, we only have to make it continuous when x equals -2. So while we do have formal rules that defines when a function is continuous at a point, given here, I think it'll be more helpful if we take a look at this graphically. Remember, if a function is continuous everywhere, we should be able to sketch it without lifting up our pencil. So for example, if this was our piecewise defined function, this would be continuous everywhere, because notice how we can sketch this graph without lifting up our pencil. But if this was the graph of our piecewise defined function, notice how this would not be continuous at x equals -2, because we have a break in the graph, and we have to lift up our pencil in order to sketch the 2 pieces. So we want our graph to look like this. That means that when x equals -2, the 2 function rules must equal each other, meaning mx minus 2 must equal x squared plus 2x minus 6 when x equals -2. So I can set this up as where we should be continuous. For example, if this was our piecewise defined function, this would be continuous everywhere, because notice how we can sketch this graph without lifting up our pencil. But if this was the graph of our piecewise defined function, notice how this would not be continuous at x equals -2, because we have a break in the graph, and we have to lift up our pencil in order to sketch the 2 pieces. So we want our graph to look like this. That means that when x equals -2, the 2 function rules must equal each other, meaning mx minus 2 must equal x squared plus 2x minus 6 when x equals -2. So I can set this up as an equation and then solve for m. Again, in order for this to be continuous everywhere, mx minus 2 must equal x squared plus 2x minus 6
at 2.
When
at -2
equals -2. So for the first step, we'll substitute -2 for x. So m times -2 is -2m minus 2 equals -2 squared is 4, plus 2 times -2 is -4 minus 6. So now we'll solve for m. We have -2m minus 2 equals, this will be -6. Add 2 to both sides. So we have -2m equals -4. Divide both sides by -2. So we have m equals positive 2, which means in order for this function to be continuous everywhere, the first function rule would be f of x equals 2x minus 2 if x is less than or equal to negative 2. Now let's go back and take a look at our graph. When x is less than or equal to negative 2, the function rule for this line here would be f of x equals 2x minus 2. And then when x is greater than negative 2, the function rule is f of x equals x squared plus 2x minus 6 as given. So again, we found that m must equal positive 2 in order for this function to be continuous everywhere. And if we wanted to, we could now go through each of these rules for continuity at a point when c equals negative 2 to verify that it is continuous at that point. But we can tell from the graph that it is. Okay, I hope you found this example helpful.
Probably did. Ah, I still got the paper. Shoot. And I really don't need this in my bag at all times. It'd probably be useful to actually store it, like here. Where the spot is in. At, I'm going to say just at negative 2. Now let's see. What did the guy do? I've got no idea. I was so zoning out during that. I couldn't help it. Couldn't help it, man. Sometimes you just can't help it, man. But no, I'm gonna have to watch a video. What do you do? Should just be plugging in 2 or negative 2, right? So m times negative 2 minus 8 equals negative 2 squared plus 2 negative 2 minus 6. And negative 2 squared is 4 plus 2 times negative 2 is negative 4. So minus 6. 4 take away 4, that's just going to be negative 6. And this is going to be negative 8. So what we could do is we could add 8 to both sides. So m times negative 2 equals 2. And divide both sides by negative 2. So that m equals negative 1. Yeah. Oh, that's so good. That's so good. Sweet. Oh, that's so good. Alright. I'm assuming this is the same thing. It's continuous because blah 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 blah. The only thing is now it's a variable. What? How the heck? C squared minus 2 equals 6 times C minus 11. Well, I'm going to add 2 to this. So it's C squared equals 6 times C minus 9. Yeah. And then I could divide this by C and divide that by C. No. Huh. Oh, you know what I could do? C squared minus 6c plus 9. 9, 1 and 9. Is that really it? It's just 1 in itself. 9 divided by 3. It's also 3 and 3, which can, so it's going to be c minus 3. C minus 3. So c equals 3. C can equal 3. Is that what I'm getting? Oh my gosh. I gotta make sure I recorded that. Oh, that was so good. Oh, that was so good. I'm so happy. Woo, woo. Oh my gosh, hello. 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 No. He's out back. He's out back. Love you, bye. Okay. Oh, I just did this. It's continuous, always true. Whoa. Do this again. Yeah. Yeah. Suppose it's a continuous function. Always true. Suppose it's a function. Ooh, sometimes true, sometimes false. What? Now it's question 12. Yes. Oh my gosh. This means I can stop for a minute and eat some pizza. And then, actually, the video is going to be over. And then I'm going to take the test. Probably gonna, let's see, what time is it? 7? Yeah, it's about 20 minutes to 7. I'm probably gonna take the test at 8, open it at 8, have it up through till 10, and I should be good. That should be a nice break. In fact, so far I've worked for over 12 hours today, with the bulk of it being math, a little of it being chemistry, but who needs it? Who needs chemistry? Who needs it? Math is the only thing anyone ever needs, ever. Continuous function. Always true. Done. 100 points. Let's look at this grade book. Let's look at it. Everything from assignment 0 till 2. Bam! Haha, take that! That's where the test ends, sucker! I can't believe I got a 99.2 on that. I don't care, I guess. It doesn't hurt me. Same thing with this one. I don't know how I don't know. Alright. Well. Thank you guys for watching. This was so great. Oh my gosh. Studying for math. I'm looking at myself. If I put this really close to the camera, it'll look like I'm looking at the camera. Close enough. Getting a phone call. Hello? Oh, thank you. Alright, love you, bye. Yeah, thank you guys for watching. This is the conclusion of this. Haha. This is, so far, what you study for on the first math test in MA 151, otherwise known as Calculus 1, when it comes to engineering, math. Engineering's first math test. This is how you prepare for it. Fully, live, kind of. Thank you guys for watching.